Hello, welcome to another productization presentation. So it's going to be a brief one for a topic that's kind of a big one. We at Camelot love our projects and our products. We treat them equally, and every time we have a debate if something needs to be productized, a lot of things that we're going to touch today come to surface. So we, as engineers, we have worked in many projects that we have loved, and we hoped that we continue working on. We'd like to have a big roadmap, to continue these projects. And also companies at the same time want to increase their productivity and profitability. In our DNA as engineers, we want to reuse code and sometimes not just reuse code, but become a little more crazy and create libraries, even frameworks. And that's being translated on the business world with products. Companies and software engineers, we are aligned on the necessity of reusing our work and creating products because we don't do redundant work, and we focus on on the actual thing, actually innovating and creating technology that matters, and not continue developing the same thing again and again. On the other hand, going to a product idea sometimes is not the best thing to do, because you have to weigh a lot of things. You have to see what this will mean for your current project, if this will affect your timeline, your time to market. And you need to see, you need to see actually if this is the best thing for your project, okay? Or you need to go another time and develop the same thing. On the other hand, if you don't do that, you continue being on single-tenant architectures and you don't make changes, you might find all these things in front of you on your daily basis and actually waste resources doing redundant things. But also we have to think that going to different architectures might affect also your development, and actually might be another bottleneck in your productization. So sometimes it defeats the purpose, okay? It's not the best thing to do. It's a concept that you have to think again and again. So first of all, during the process, you have to define some things. You have to define actually what is going to be the actual product. If it's going to be a library that you're going to reuse inside your organization, a whole framework, or even just an API, an application or integration layer, whatever. But the first thing you have to identify here is what can be productized from your current project. And secondly, what is your offering, what you want to productize. And another thing that you have to see also as an engineer, and don't get this wrong that this might be a little more business oriented, but you have to identify if it's going to be a B2B or B2C. And actually you have to identify the volume of your clientele. Although this seems to be very, very business, it's going to affect you a lot. So during the process, you have to figure out what is the best architecture for yourself, your company, and your product. So some of these, some of the things that you have to do actually is to figure out what is the gap, what you have to do on your current project, and actually convert this to a product. Figure out what is going to be your strategy on all your daily things like deploying whatever it is. And secondly, you have to identify also what is going to be the level of adaptation, if you're going to provide customization, and so on and so on. Everything is going to change. It's not creating, transforming from a project to a product is going to change a lot of things. So you have to see if it's actually worth it, okay? And you have to see if the biggest thing, the biggest concern here, if shifting to that approach is actually aligned with the company strategy. Is this exactly what you want to head to? Okay, so yeah, and as Ari, that will continue the presentation for you, is gonna touch, a lot of things will change, and actually this will be on the way you deploy and backup and recovery and all your BAU. But of course, everything that happens, on maintaining code especially, and you have to come to a model that best fits you and is most effective for your team on both platform resources and, of course, the team. Erin?
So thanks, Sudhir. So hi from me as well. So today we're going to be discussing, at least on a high level, some key areas that you need to focus when we are trying to go from a single client database to something that is more multi-tenant, that is opted to go out as a product to multiple clients. Of course, there is no solution that can fit every product. It's not something that can easily fit into a guideline. So try and think for the above presentation, something like a handbook that you can look to in order to see the key areas that you need to focus and what you have to have in mind when going this way. Most of them are part of what we have been experiencing from our teams when going down this road in order to go into a productized database project. So it's more like some thoughts that come from experience and the development teams that have been working with us. So to start from the basics, the most important bit is actually to keep in mind that you need to stick to one code base. There is literally no other way to go around it. You must stick to having one code base for every customer that you are going to serve. So that means you can't go into forking, you can't have long-lived release branches. I know that sounds like a dream for most projects, and it's quite difficult to achieve, but if you don't do that, then you end up with quite a lot of maintenance effort down the line in order to be able to support different release branches for each customer and to bring them up to date with your main productized code base. Quite a lot of times you will have to choose that for different customers you need to enable different features. They are things out there that you can use, like feature toggles that can help you enable selective functionality for your API. Generally try and think that every new feature that goes to the code base has to be adapted to be enabled or disabled for its client. When you need different implementations for its client, there are quite a lot of design patterns that you can rely to. Try and use them as much as possible, for example, strategy patterns, in order to come up with a different implementation for its client. And I think the most important of them all is that you need to be aware of breaking changes. This is quite difficult to navigate when having to deal with legacy code as well, or with contracts that have been made in the past with other clients. But the moment we introduce breaking changes, you are having a problem with release management. Consider using API versioning in this case, so you can have your tenants use the current version of the API until they are able to go to the new version of it, and you can roll out the new release without having to introduce downtime and breaking changes on their side as well. So why is this important? Everything stems from the basic principle of code once, deploy everywhere. When you have one code base for all tenants, this facilitates both your release strategy. There is less effort to code maintenance, and there is less effort to add new features as you only have one single source of truth for your code base. And finally, something that is important for the day-to-day tasks, your test, your code verification, your security pipelines, your performance testing, and everything that you will add to your code base, everything runs under the same code. So even your pipelines are easier to control in this way, and you don't have to have extra maintenance even for the operational work. The second main pillar of going into a multi-tenant database is how to manage the branching and the release strategy. This is a problem that has been, quite a few years in the industry. When you talk about a productized code base, the only way to go is probably to go forward with incremental releases and try to have trunk-based deployment where you add new features, and every time you have some major release, then your tenants will receive the updated version of your code base. This needs a branching strategy that can support this principle. There are quite a few out there, like GitHub Flow or OneFlow, that enforce the principle of having one main code branch that has the latest features and is a production candidate for you. And you can have hotfix also releases for production deployments in case you don't need to roll out a major release yet. There is no correct choice on this one. It's what fits best your development teams. But we strongly suggest to stick to a branch strategy that enforces the way of development with a main trunk branch like GitHub Flow and OneFlow. The most difficult part of all in the whole endeavor is choosing the right architecture for your software. We cannot possibly cover this in the project here, but at least we can give you some basic guidelines about the most popular solutions given all the constraints of your software. It's quite a difficult choice. There are a few things that can help you narrow down your choices and can help you choose what is best for your case. One main constraint that probably can narrow your choices quite a lot is whether you have strict requirements on data isolation regarding the security of your clients and whether you also have strict requirements of the location of your data. If your tenants need, for whatever reason, due to the data of the application or due to regulations, to have the data located on a specific geographic location, then it means that you can't really go with any other model. So in this case, you have the multi-tenant app single database model. In this case, your app is tenant aware. That means that you have one single version of your app. All nodes can facilitate requests from all tenants on your cluster, but the database layer is segregated, and each tenant has an isolated database cluster on its own. Essentially, this is required in case your data needs to be on a different location than your app, and this might be the case when you host financial data or data that are under legal restrictions. This model has the greatest level of isolation and security. Generally, it scales well on the app level because all you need to do is to add more nodes if you have more traffic incoming. But the operational cost of the database is quite high because you have to scale the databases independently and manage the allocated operational cost accordingly. It's a good model when you have like few tenants, but when your enterprise grows, it's quite difficult to manage the complexity of having multiple data centers and how to scale them. So as a rule of thumb, if none of those restrictions apply, then you can probably go with what we call the most simple of all models, which is a multi-tenant app with a multi-tenant database. Essentially, it is similar with the other model in terms of having one app that serves all tenants, and it's not dedicated to a client. But there is also one database that is used for every tenant that uses your product. In this model, the only constraint is that your schema needs to be adapted in a way so that data are associated with the client. That is quite easy to achieve. You can have client-specific IDs on data in order to associate it with them. So it's not that much an effort in terms of designing your database. Horizontal scaling works best this way because you either have to scale on the app level or add more clusters, add more resources on your database cluster. In any case, you only have one thing to manage. So generally, the operational costs are quite low. What you need to be aware, however, on this model, because it does have its downside, is that we have what we call the noisy neighbor impact. This means that if you have incoming high load from one tenant, then probably this will impact the services and the SLAs of the rest of your tenants. So you need to be very aware of your scaling strategy and your throttling strategy so you don't waste resources and you are able to facilitate incoming traffic without introducing bottlenecks to others. The same complication applies to the downtime. If you need to roll out releases for hotfixes or whatever for one of the tenants and you need to take down part of your cluster, probably you will have a global downtime for everyone. This is not always acceptable for tenants, and you need to be able to use a strategy that facilitates this for deployments and have a zero downtime policy. Finally, it's quite important to have in mind that application security is quite critical in this case. Tenants might need to have critical standards on security. It's important to test that they are not unauthorized access either to data or to functionalities that they don't need to access. The next pillar that we're going to discuss is testing. Generally, we cannot stress that enough, relying on automation as much as possible for everything that you can. for your functional and regressional testing, for end-to-end, for security, be that static code analysis or a live server testing like a WASP, and of course your performance testing, which is going to be quite important when going out on a scale-out scenario. You need to be able to test out all permutations and features that you support as your core suite. So that means that if you have feature flags, you also need to test that enable or disabling parts of your software does not have unintended impact on other tenants. And finally, it's quite critical to test that your API is also tenant aware. That means that parts of your database are not, cannot be accessed by unauthorized tenants. So you need to be aware of security testing. And also that the tenants, they are not able to use functionality that they are not authorized to. So that means that your API should have proper security, and the security should also tie into the identity of the client. The other important bit that is more related to testing, but it's quite critical when scaling out on a cloud-based application, is performance. Probably you are already aware of this, but let's just go over the basics here. The most important thing is to, first of all, benchmark your app. It's a step that we usually skip and leads to quite a lot of trouble down the line. If you don't benchmark your app at a lower level to find the access patterns on the database, your memory usage, your CPU usage, what are the minimum requirements of your app and how optimized it is. If you don't do that, then you don't really know if you're actually using your app the best way it means to. This will help you drive your requirements in terms of hardware and resources, and it will help you understand how your application works when it is stressed. The next thing to determine is whether your app is able to scale horizontally. It might not be the case. All apps have a bottleneck somewhere. For some applications, it's a database. For others, it's a critical workflow. It might be something else for you. Depending on the nature of your application, you need to be aware exactly what are your performance caps, and even if it's able to scale horizontally or it needs to scale vertically. Another thing to discuss and to be aware is that you need probably to start some discussions early on for the intended SLAs that you're going to provide to your customers. Quite a lot of times we don't do that, and it's quite critical to know that from the start, because this is going to drive both the performance goals of your application and what will be your allowed time windows for availability and downtime. It's also quite important, as we said before, to validate the noisy neighbor scenarios. So use testing that emulate cross-load for multiple tenants, for key workflows on your app. Do not rely only on single tenant testing, because this is not something that will realistically happen on production. So you need to test load from multiple sources, to test your scaling strategy, which means that both auto-scaling and throttling down should be tested exhaustively, and to see how that applies on a production system. Finally, something that is quite important is to test the impact of onboarding a new tenant. Essentially, what does it mean in terms of resource allocation, in terms of the impact of others, and to know exactly the handbook that you need to follow when you onboard a new tenant or your cluster. So the final thing that we need to discuss here is probably the deployment strategy. Again, this is quite complex to cover here, so we will just have some high-level overview of the basic issues that you need to be aware. I think that's the main thing that drives the whole deployment strategy, is whether you are allowed to have a zero downtime policy, or is a window, a small maintenance window, acceptable for your business. This depends on the nature of your application. It might be that you are not allowed to have a maintenance window at all, so you need to pick a deployment strategy that will probably switch between data centers to enable deployment between the new version and switching from the old to the new. If you are able to have a maintenance window, perhaps you can use that in order to roll out selectively the updates that you need and have any window for supporting the tenants in the meantime. The second critical question is whether your app is able to coexist with different versions on a live server at the same time. Essentially, that means that if your application can have multiple versions with no functional impacts at the same time, you might be able to use a policy that can update selectively the nodes of your app in the cluster in one go. If this is not the case, then probably you need to have a policy that shuts down and updates everything in one go so that you don't mix and match versions. Another thing to consider is the business request for your tenants. Do your tenants need to update under specific time slots due to legal reasons, due to having high traffic times that they need to avoid deployments during those? And you would like them to, and they would request to have updates and receive them at a different time zone. In this case, you need more complex update strategies. There are quite a lot of there that can be applied to enterprise clusters. For example, like deployment stamps, where you have to segregate a single unit of a cluster that can serve your tenants and then update them sequentially. Also keep in mind that there are also tools like API versioning and feature flags that you can probably use in order to restrict the usage of new features to new tenants until they are able to actually use them. And the final thing that you need to be aware when choosing a deployment strategy, and it's quite important, is to decide what to do when things go bad. Are you going to support a rollback policy, or are you going to support a fixing forward policy? Essentially, this is something that can be decided depending on the nature of your software. There are both good things and downsides to both of them. For example, consider that rollbacks are something that have quite high operational impact. They might require rolling back from third parties as well, and they will have always a higher operational impact. However, a fixing forward policy is something that is quicker if you have a development team that can address the issue. But sometimes it might not just be able to address a critical issue with just a hotfix at production. So that's the closing words. As Jerry said, multi-tenancy is quite a long journey. It has quite a lot of difficulties down the line. We didn't even cover the tip of the iceberg, I think, here, but I hope that it was a good introduction to the issues that you're going to face. You probably will have to revise decisions that you have made early on. It's quite difficult to predict everything up front, so do not expect to find solutions to everything up front, but do not be dissuaded. There are quite a lot of success stories that you can draw experience from. So the best you can think is, to hope for the best and be prepared for the worst case on your software, and most importantly, to have your teams excited, because these are the people that are going to help you to go and drive your project. So yeah, thank you for your time. And